Good morning, children. So now we are going to discuss the topic of a potential energy of a spring. So in order to discuss the topic potential energy of a spring, so we have to consider the case of a spring in which one end of the spring is fixed and on the other end there is a massive body is attached. A massive body which is having mass m is attached and which is stationary. So we can say that this is the equilibrium position of this object. So let x is considered as x is equal to 0 is the mean position or equilibrium position of this object. Now we are considering the situation as when an external force is acting on this spring. You can see that. So this spring can be displaced from its mean position. Like this spring can be displaced from its mean position. Let x is considered as the displacement of this spring. When an external force is acting on this spring. Let this is the external force is acting on this spring. So this spring can be displaced from its mean position. And corresponding displacement is x. You know, when an external force is acting on this spring, always there is an opposite force is developed. So that force we call it as a restoring force. So there is a restoring force is always developing on this spring, which is in the opposite direction of the external force. And remember, this restoring force is directly proportional to the displacement and which is in the opposite direction of the displacement. So we can say that F is proportional to what is that minus of x, or F is equal to what is coming minus of k into x. So where k is known as a spring constant. So we can say that k is considered as a spring constant or a force constant, that is represented as a k, small letter k. So F is equal to minus of kx is considered as our restoring force is developing on this spring. And we know this restoring force is always equal and opposite to the applied force, external force. So we can say that F external is equal to what is coming is equal and opposite. That means minus of F we can say. Or we can say that F external is equal to what is coming is equal and opposite to that. That means k into x we can mention. So this is the way we can find what is the value of external force is acting on this spring. Now we are going to find the what is that. So we can see that external force is acting on this spring. There is a corresponding displacement. That means there should be a work is done. So we have to calculate what is the corresponding work done in this case. So in order to calculate this work done, so initially we have to calculate what is the work done for a small displacement dx. So we can consider a small displacement dx. The corresponding work done is considered as a dw. So dw is equal to what is coming F external dot dx we can say. So this is the corresponding work done during a small displacement dx. So we can mention dw is equal to what is coming dw F external, that means F external dx cos 0 is. Now we know what is the value of F external. What is the value of F external? Kx. So our equation becomes Kx into dx. So Kx into dx we can say that this is the value of a small work done. Cos 0 is considered as 1. So the equation becomes Kx into dx. So this is the corresponding work done for a small displacement of dx. So our spring is moving from corresponding position x is equal to 0 to what is that x is equal to x. You can say that. So in order to calculate the total work done, we have to integrate this equation from 0 to x. So integral of dw is equal to integral of x is equal to 0 to x is equal to x, which is ranging from kx into dx. So this way we can integrate this equation. So corresponding work done is equal to what is the value of work done? K is constant, so we are taking outside k into integral of x dx is what is coming x square by 2. We already know this x square by 2, which is ranging from x is equal to 0 to x is equal to x. Now we can substitute the upper limit, it becomes x square by 2. and lower limit is 0 only, so that time becomes a 0. So negation for work done is corresponding, what is that? Half k into x square we can say. So this is the corresponding work done. This is the corresponding work done to displace this spring from equilibrium position or a mean position to this maximum position of x. And this work done is stored in this spring as a potential energy. So this work done to displace this spring is stored in the form of a potential energy. So we can representing this equation as potential energy stored on this spring as a U is equal to what is coming half k x square. So this is the case of a potential energy of a spring, we can say. So potential energy of a spring is given by U is equal to half k x square. Okay, thank you.